Today's lesson we'll be talking about section 6.2, trigonometry of right triangles. These are the 6 trigonometric functions that we use when talking about right triangles. Now, mainly we'll be talking about sine, cosine, and tangent. We also have cotangent, cosecant, and secant. Okay, sine, when talking about from an angle, you can talk about like how the side is oriented compared to that side. So sine of theta would be the same as the opposite side divided by the hypotenuse side, which is always the longest. Cosine is the adjacent side, which is right next to that angle, or the angle that, or the side that is not the hypotenuse, divided by the hypotenuse. And then tangent is the opposite side divided by the adjacent side. Cotangent is the reciprocal of tangent. Cosecant is the reciprocal of sine. And secant is the reciprocal of cosine. So using those, we want to be able to write each trig function given a trig ratio. So let's say we have a triangle, and we are always talking about a right triangle. So we say cosine of alpha, so let's say this is alpha, is the same thing as 2 over 7, and I want to find the other trig functions based on this. So my adjacent side would be right here, 2, and that's divided by the hypotenuse, which is 7. And also the hypotenuse is always opposite of the right triangle. Now, what I need to do is find the opposite side. So I need to use Pythagorean theorem to help me find the other missing side so that I can find all my trig ratios. So here I would take 2 squared plus, and let's call it O, or actually, let's call this A to label that side. So A squared, and that is equal to 7 squared. So 2 squared is 4. And plus alpha squared equals 49. I would want to solve for alpha, so I want to subtract both sides by 4. That gives me 45. And then taking the square root of both sides, I can reduce this into a factor tree. So it looks like I have a group of 3s that I could pull out, so this is reduced to 3 square root of 5. Okay? Now I know when I put in a square root, it's usually plus or minus, but because we're talking about a physical thing, in this case just a normal right triangle, it will always be a positive value because we're talking about distance. So using this, now that I have what this value of A is, now I can set up all my other trig ratios. So sine of alpha is going to be the opposite side over the hypotenuse, so we have 3 square root of 5 over 7. Then from there I want to find tangent. Now there's no real order to any of these, so don't think that you have to go in a certain way. Tangent will be 3 square root of 5 over 2, which is the adjacent side. Cotangent will be the reciprocal of tangent, so it would be 2 over 3 square root of 5. Here I'd like to rationalize Usually this is a good habit to get into, especially when we're talking about stuff on the unit circle that we'll talk about later. So here I get 2 square root of 5 over 3 times what square root of 5 times square root of 5 is, which is 5. So 3 times 5 is 15. Cosecant will be the reciprocal of sine. So that gives me 7 over 3 square root of 5. So do the same thing, rationalize. So that gives me 7 square root of 5, and then these combine to make 5, so it's over 15. And then the last one is secant. Here it's the reciprocal of cosine. We were given cosine to begin with, so the reciprocal of 2/7 is 7 over 2. So then that would be all of my answers to find the trig ratio. Now here we need to talk about special triangles. Now there are 2 special triangles. You have a 30-60-90 triangle and a 45-45-90 triangle. So let's say that this side over here is 1. Okay. Now usually with a 30-60-90 triangle, the hypotenuse is double the shortest side. So in this case it would be 2. And the longest side that's not the hypotenuse would be the shortest side times square root of 3. So here in this case we'd have 1 times square root of 3, which is square root of 3. Now also doing the same thing with a 45-45 triangle, one side can be a unit of 1, so then the other side, since it's a isosceles triangle, the other side would be 1, and then the long side, or the hypotenuse, would be square root of 2. Okay, so using these values, we can figure out some different values to use for shortcuts. This will jump into our unit circle that we talk about later down the road. So just to clarify, 30 degrees is the same thing as pi over 6. 45 is the same thing as pi over 4. And 60 degrees is the same thing as pi over 3. Now if I'm talking about sine of 30 degrees, if I go to my triangle, the opposite over the hypotenuse, it gives me a value of 1/2. And then cosine would be the adjacent square root of 3 over 2. Okay? And then tangent will be the opposite over the adjacent, so it will be 1 over square root of 3. Now you can choose to rationalize that. So multiplying by square root of 3 top and bottom, I'm just going to erase this. So then that gives me square root of 3 over 3. Then cosecant's the reciprocal of sine, so that's 2 over 1, which is 2. Reciprocal of secant would be 2 over square root of 3, so rationalizing gives me 2 square root of 3 over 3. And then the reciprocal of tangent, if you go back to the previous one, it was 1 over square root of 3. So then flipping that would just give us the value of square root of 3. Okay. Now using that for, let's say, 60, if you think about 60 degrees, the opposite over the hypotenuse is going to be square root of 3 over 2. Okay? The cosine of that is the adjacent side over the hypotenuse, which is 1/2. Now if you could kind of see, the sine and the cosine, or the sine of 30 and the cosine of 60 are kind of the same, and vice versa, the sine of 60 and the cosine of 30 are the same. So here, all of the values are going to kind of be like interchangeable. So square root of 3 over 3 for tangent is going to be the same thing for the cotangent of 60 degrees, which will be the same, or tangent of 60 degrees will be the same as what the cotangent of 30 degrees was. Okay? And then, following that same pattern, cosecant of 60 will be the same thing as what the secant of 30 was, because they're kind of interchangeable. So 2 square root of 3 over 3. And then cosine is the reciprocal of secant. It gives me 2. Now for pi over 4, or 45 degrees, you have 1 over square root of 2 for one of the values. Now, if I rationalize that, multiplying across by square root of 2 gives me square root of 2 over 2. Okay? Cosine will be the same thing because it's 1 over square root of 2 as well. So square root of 2 over 2. And then tangent will be 1 over 1, which is just 1. And now from here, we can kind of do cosecant and secant. If we go back to this previous one where we said is 1 over square root of 2, so cosecant of 45 would be square root of 2, secant would be square root of 2, and then cotangent is the reciprocal of tangent, which is still 1. So now let's try an example here using this. So here I want to find A in the given triangle. I'm given 30 degrees. I want to find the opposite side here for the value of A, but I'm given the hypotenuse. So here I need to use the value of sine of 30 degrees to help me find what A is. Now I know what sine of 30 is. If I look back, sine of 30 was 1/2, so I can insert that value in, and actually now it's a proportion, so I can cross multiply and sum. So 1 times 10 is 10, 2 times A is 2A, I can divide by 2, and that gives me a value of 5. Okay? So that's basically how the majority of it works. You'll be given word problems that do the same kind of thing. So you'll need to set up the triangle based on the scenario that they give, and then use your values to help you simplify to get the answer that you want. To memorize, going back to the table, it'll be helpful if you memorize these values, as they, once we get more into the unit circle, we'll come across it more and more as we move through the chapters. So memorizing those values will help you a lot. Okay? Have fun.